Welcome class 10. Today's topic is conservation of energy. So first we'll start with the principle of conservation of energy, which states that energy can neither be created nor can be destroyed. It only changes from one form to another. So this simply means that energy cannot be destroyed, neither it can be created. So only there is a transformation of energy from one form to another form of energy. So let's try to understand it with the help of some examples. So here the energy gets transformed to some other form of energy, and here the total energy always remains the same. If you talk about some mechanical energy, then in mechanical energy, the potential energy gets converted into kinetic energy, so that the sum total of energy always remains the same. So we can say the the kinetic energy K and the potential energy U is always added up as constant. So K plus U is equal to constant. Now let's see a mechanical energy conservation of conservation of energy out here. So let's say there is an object placed at the height h above the ground, and let's say this point is point A. So at point A, the initial velocity will be equal to 0 because the body is at rest, because it has not started falling, so its initial velocity u will be equal to 0. So the kinetic energy, if the velocity is 0, then we can say the kinetic energy K also equals 0. Thus, when the potential energy we talk about, potential energy we know the formula is mgh. So over here, m is the mass of the object, g is the acceleration due to gravity, and h is the height at which the object is placed. So here the height is h. Therefore, the total energy will be equal to, the total energy in this case is the mechanical energy, which is equal to K, the kinetic energy, plus potential energy U, which is equal to the kinetic energy we have already said it's equal to 0 out here. So 0 plus mgh, the value of U. So the total becomes equal to mgh. So the total energy at when the body is at point A is equal to mgh. Next, suppose the body starts falling now, okay, and reaches at point B. This is the duration where the body is still falling. So at this point, let's say at point B, it has covered the distance of x. So x distance has been covered. So at point B, we can say that the velocity acquired at this point, let's say it is v1, and let x be the distance traveled by the body up to the point B. Then the initial velocity u will be equal to 0 because it has started from point A where its initial velocity was 0, and its final velocity, that is the acquired velocity, now has become v1, and the distance traveled is equal to x. And we know from the laws of motion that v squared is equal to u squared plus 2as, where v is the final velocity, u is the initial velocity, a is the acceleration, and s is the displacement. So here the final velocity is equal to v1. So v1 squared, initial velocity u is equal to 0. So 0, and 2 acceleration due to gravity g, and x is the displacement. So v1 squared will be equal to 0 plus 2gx. So v1 squared, on further simplifying, will get equals to gx. And we know that the kinetic energy K is equal to half mv squared in this case it will be half m v1 squared, because the velocity is v1, and v1 squared, the value is equal to 2gx. So we'll put the value of v1 squared as 2gx. So we'll get half m into 2gx, where this 2 in the denominator and 2 out here cancels, and we get mgx. So the kinetic energy at point B will be equal to mgx. Now this is the total height, and this much amount of distance is x. That means from here to here the height at point B will be equal to h minus x. So the potential energy will be equal to U equals mg, and this height h minus x. So mg into h minus x. So the total energy will be equal to the potential energy plus the kinetic energy. So kinetic energy is equal to mgx, and potential energy is mg h minus x. So this two energies are added. So on further simplifying, we'll get mg into h is equal to mgh, and mg into x is equal to minus mgx plus mgx, where minus and plus mgx will cancel, and we'll get the value equals mgh. This means at point B the total energy is equal to mgh. Next we move further, and let's say from point A now the body falls and reaches point C, that is on the ground, where the height becomes equal to 0. So at this point, at point C, let's say the velocity v be the velocity acquired at point C, that is the final velocity v. So initially it started with the velocity u, which is equal to 0, and the final velocity now has become v, and the distance it has traveled is h. So the distance s is equal to h. Again, using the laws of motion, v squared is equal to u squared plus 2as, we'll get v squared, the final velocity, is equal to 0, initial velocity squared, plus 2 acceleration due to gravity g into h. So s is h. So this is equal to v squared is equal to 2gh. Now the kinetic energy we know is equal to half mv squared, where v squared is equal to 2gh out here. Alright, so replacing v squared by 2gh, we'll get half m into 2gh, where 2 in the denominator and 2 out here cancels. So we'll get mgh. And when the body reaches the ground, the height becomes equal to 0. This means that the potential energy also becomes equal to 0, because mgh, that is the potential energy, h becomes equal to 0. So potential energy also becomes 0. So now we can say the total energy is equal to k plus u, the kinetic energy mgh plus u, the potential energy. So the sum of mgh plus 0 equals mgh. So here we can conclude that when the body was at point A, the total energy of the body was mgh, that is the total mechanical energy. When the body reaches point B, alright, so at that time also the total energy is equal to mgh. And further, when the body moves down and reaches the ground, that is point C, at this point also the total energy is equal to mgh. So here we can understand that how the total energy is conserved, the mechanical energy. When the potential energy is decreasing, as it goes down, the kinetic energy will increase, and when the kinetic energy becomes maximum at point C, the potential energy becomes minimum. And similarly, when the body was raised at a certain height A, the potential energy was maximum and the kinetic energy was minimum. So here the conservation of energy, the principle of conservation of energy is valid, as we can see the total energy is always mgh at any particular point of this free fall of the object. Next is, if we take a simple pendulum and the simple pendulum starts oscillating to and fro in a motion, then here it reaches the two extreme points. Okay, this point is called the point A. This is called the mean position. Then it reaches the right extreme point, point B, and again it reaches point C, the other side, the maximum point. So here again, with the help of conservation of energy, we can understand that at point B, when the bob was released from this point B, it had the maximum potential energy because this was the height, okay, from here to here, the height h, and at that point the potential energy was equal to mgh. So u is equal to mgh. So when it was kept out there, before letting it go, its kinetic energy was equal to 0. And at point A, when it reaches point A, when it is released from point B, it reaches point A. At point A, its potential energy becomes 0 and its kinetic energy becomes maximum, that is half mv squared. And according to the conservation of energy, its half mv squared, that is the potential energy, should be equal to its kinetic energy should be equal to the potential energy mgh. So half mv squared must be equal to mgh. And at point C, when again it reaches the other side with the maximum height, its potential energy u becomes equal to mgh, and here again the kinetic energy becomes equal to 0. So we can say the total mechanical energy always remains constant or same.